Hey, welcome back to Fat Mama Physics. In this episode, this is the last section of Unit 3 on polynomials. We will be multiplying and dividing a polynomial by a monomial. So a monomial, don't forget, has both a coefficient, so a number, and it also has variables. So this is where the essence of my example with the fractions and the board game called Star Realms is going to come into play, because we get to talk about when numbers have to treat numbers and variables have to treat variables. Okay, let's do a little quick blurb on, of course, since it's a new section, we introduced a board game, but actually I'm going to keep this very short because it's going to be very similar to the last lesson, and this lesson itself is not too long either. So let's get down to business. Over to Star Realms. So again, this is Star Realms again, but I did say in the previous episode I'm going to introduce an expansion here. So the expansion is the following. It's has to do with heroes. It's a heroes expansion. So just like any other ship and any other base, star base, you get to pick these up, buy these at the cost at the cost at the top of the card here, worth 4. And whenever you buy this guy, he actually stays in play out in front of you. You don't get to shuffle him back into the deck, which is actually a good thing. It keeps your deck thin, and whenever you buy him, you can use his top ability, and which also provides you with a symbol for that particular turn, which might come in handy for timing and whatnot. And whenever you want, on any of your future turns, you can choose to scrap him, which you see this little garbage can symbol. You can scrap him to get the symbol for that round, so good timing is important there. And you can activate the text. You can scrap a card in your hand or discard pile. So this guy is a scrapper, just like any other old machine code card. So he does follow that trend, that theme. So there you go. That's what these heroes are able to do. So there's different kinds of heroes, of course, from different fractions and the like. And it kind of gives this game, like, especially if you are just stuck, and usually if the trade row, there's just nothing there worth buying, and you just have a whole bunch of money, and you're just sitting waiting for a good card to come up, or you or your opponent are just stalling one another and not trying to buy cards to reveal more cards from the deck, then these captains or these heroes are a nice outlet to kind of give you an edge in very specific moments. But anyways, just to reinforce the fact again that if I have that particular symbol, it only activates the bottom text of my other cards that I've played that round. So, for example, I can only activate these cards, the yellow Star Empire fractions. I can't activate, for example, someone from the blue fraction, which is this Frighter card. So I can't activate those texts. So the fractions have to match in order for the ships to be able to cross-activate their other abilities. And same thing if the commander's in play, or sorry, this commander, the heroes in play might be able to help you pair up those symbols to help you activate the bottom text. So the fractions are specific to each other. Just like in our lesson, the numbers will only affect the numbers and the variables will only affect the variables. It's like there's only one, it's like you have one particular cure for each disease or something. So the target is specific. Target specific. So let's go back to the lesson. Thank you for joining me in this game. Okay, so back to our lesson on 3.5, multiplying, dividing polynomial by monomial. Alright, so let's do a bit of a review. So, there are two concepts that are important here that I expect you to know well. Number one is your exponent laws. You need to know your exponent laws very well, meaning that you need to know what happens when, say, let's say you have x and x multiply one another. They have an invisible exponent of 1, so 1 plus 1 is equal to 2. And if I have x to the power of 2 times x to the power of, well, 1 in this case, then I add the exponents up. That gives me x to the power of 3. Division is the opposite, so you subtract the exponents instead. That I need you to know very well. So for example, b, this would just be w squared. And whenever you say you have, let's say, if you have a number multiplied by a, let's do a side example. If I have 4 times 4a, and that's kind of the opposite of c here, then the 4 only applies to the 4, so following the fact that the numbers treat the numbers, the variables treat the variables. Okay, so in this sense, I have 4 times 4 is 16, I leave the variable alone. Now, when I have instead 4a times a, now what's going to happen is my 4 does not have anything to multiply itself by. So my 4 actually stays what it is. So my 4 just stays there. But now I have a times a. If I have a times a, then that's just a squared, right? Because if I rewrite this out, this is 4 times a times a. I combine the a's together to be a squared, and 4, we can't do anything with 4, right? And same thing with d. D, we just add a little bit of extra. So in fact, this is negative 3 times a times 6 times a. And of course, we're going to combine things that are like one another. So that would be the a, and the a becomes a squared. A negative 3 times the 6 becomes a negative 18. So we have negative 18a. Okay? Of course, you don't have to write this here. I would just go ahead and go negative 3 times 6 is negative 18, and a times a is a squared. So notice the numbers target the numbers, variables target the variables. So now hopefully that is out of my system. I can stop talking about it. We can go ahead with our lesson and do practice. So let's start with multiplying monomials together. So in this case, you do not need to use distributive property because there's only just one term involved anyway. So let's go ahead and do that. So I get 2 times 4, that's going to be 8c times c, that is c squared. Okay, so notice that only the similar things affect one another. Again, oh, somehow that's the same. Well, guess what? We can always spice it up. Let's say there is a square right in at the top of a c. So be careful, this is not outside of the brackets, this is just attached to the c right there, okay? So let's say if that were the case, what would this give us? Well, again, the numbers 2 and 4 are still going to make me 8, but now I have c times c squared. Remember, c times c squared is just c to the power of 3, since this c has an imaginary exponent of 1. 1 plus 2 is 3. Okay, so there, I tweaked that question there just so that we can get some variety of situations. Let me write that clearer. Okay, so now let's start doing some distributive properties, okay? Okay, so here I will end with example 2, and that will be the end of that. Or not, actually. Let's see. Okay, because the last example gets lengthy. Okay, so here we go. Let's multiply binomial with a monomial. So again, distributive property. And this time, it's kind of us extending the steps that we had before, now that we have to do this twice for 2 of the variables. Oh, sorry, 2 of the terms, my bad. Okay, so here we go. I basically multiplied 2x to 3x, and then 2x to 4. This is going to give me 2 and 3, give me 6, x and x give me x squared. And when I say and, it means 2 when I'm multiplying them together. Here I have 2 times 4, which is going to give me 8. X is lonely by itself, and I just leave it as is. Okay? How about this? Why don't you give B a try, and good luck. Give B a try. Good time to pause the video. Alright, so again, if you wrote it out like the following, don't forget you have to multiply the whole thing by negative 4c. You only have one negative, even though you have a 4 and a c, it's not negative 4, negative c. No, that's not how it works. So this is negative 4c, and in brackets 2c. And you know what? I'm going to write it this way just to show you a different way how you can approach this. So I wrote minus 3, which is the original term, and then I wrote the constant, or sorry, not the constant, the monomial that I'm multiplying in. So negative 4c like that, okay? So I just look at, there's just less things to look at, in my opinion. Okay, so again, remember, the numbers treat the numbers, variables treat the variables. So if I do that, I get -4 and 2. So -4 times 2 gives me -8. Okay, the variables are c and c. C times c gives me c squared. Do the same thing for the second term. I get, and again, I'm going to include the negative sign, -3 minus 4. So -3 times -4 gives me positive 12. Oh, so close, hey? And then there's only one c in here, so I just have to write c, and that's it. So writing this out very nicely, I get -8c squared plus 12c, just like that. Okay, so there you go. Okay, so I'm actually, I will end the video here, and I'll do example 3 and 4 in the next video, and I may even add a few harder examples for you to try as well. So I thank you for watching, I wish you the best of luck, and Fan Mama Physics signing out.